All right, now that we've learned how to do the different transformations, we also need to be aware of the fact that order matters. Just like bed mass, order of operations, multiplication, division comes before addition and subtraction. So we'll use an example here. It says use your graphing calculator, all right, to do these two different graphs. All right, so if you in Desmos enter y equals x cubed, so here is y equals x cubed, something like that. If I translate the graph 2 units down and then stretch it vertically by 3. Okay, so let's think about this graph. If I go 2 units down, this is just very rough. Don't worry, we'll talk more about this in the future. If I go 2 units down and then stretch it vertically by a factor of 3, this -2 becomes -6. This -1 becomes -3, and you have a graph that looks something like this. Okay? Why are we looking at that? Well, let's take a look now at if we do this in a different order. So here's x cubed. If I stretch by a factor of 3, so take this point, multiply it by 3, it doesn't move, and then I go down 2. You can see this graph looks a lot different than this one. These are different graphs. Okay, I would like you to try that on Desmos and see that they're different. The question is, which one's right? How do we know what we're supposed to do? Well, we'll go back to order of operations. What do you think you should do first? Should you go 2 down and then stretch, or should you stretch by 3 and then go 2 down? Okay, well, hopefully it makes sense to you that you should multiply before you subtract. So multiply by 3, then subtract 2. Okay, so this one would be right, this one would be wrong. All right, so let's take a look at transformations, combining them. So now you can have all of those things happening at once. Order matters. All right, you're going to see this equation a lot. And in that equation that we have here, it has each of the transformations. We've got the horizontal stretch or compression. We've got a vertical stretch or compression. You've got a reflection, and then you've got translation. What should we do? What should the order be? Well, generally speaking, we multiply before we add or subtract, and I would say work with all of the x's and then do all of the y's, or vice versa. Okay. Or you can leave the translation part, the moving up and down, left and right, you can leave that to the end, but do the multiplying first. So we'll do some examples, and you can see that there are several ways to do it. We just have to make sure that we do the right order. Taking a look at a point, what are we going to do to each point? We're going to do this. This looks complicated. I have never used this formula. I've always just thought, well, I'm dividing by B and I'm moving left or right by H. I'm multiplying by A and I'm going up or down by K. I mean, that's what we're going to do, but I've never really used that little formula. Okay, so let's try an example here. Here's the graph y equals f of x. So we're calling this f of x. Okay. And it says sketch the graph of its image after a vertical compression by a factor of 1/3. Okay, vertical compression means multiply y by 1/3 and then translate 2 up. Okay, and so then go up 2. All right, and we can do this in one step. So what is the y value right here? Okay, it's 1, 2, 3, 4, 5, 6. If I multiply that by 1/3, it becomes 2, and then I go up 2. There it is. That's the new point. Okay, so I've taken the vertex and moved. What else should I move? Well, probably the x-intercepts. Let's move those. So I'm going to multiply by 1/3. They don't change, and then I go up 2. So it goes there, and it goes there. And that's probably enough to draw our graph. Okay, now to be safe, because I don't really know what the x-intercepts are, maybe I'm going to draw it like this. Maybe what I'm going to do is I'm just going to sketch this but not cross the x-axis, just because I'm not sure. Okay, so that's the translated graph. transformed graph. Okay, let's try another one. Here's g of x. We're supposed to do two things to it. We're going to do what? What does that negative do? This is a vertical flip or vertical reflection, and then it's going to be up 2. I'm going to do this in 2 separate steps. So first I'm going to do the vertical flip. Okay, so what is that going to look like? Well, the original graph looks something like this. And so if I do a vertical flip, it's going to be here. All right, and then if I take that graph and move it up 2, it's going to be here. Okay, so that's how you do these graphs. Now, those are pretty simple. The graph is given for you. You just have to do some transformations. This one is quite a bit trickier. How would you do this? There's a lot going on here. Well, the first thing you should always do is to graph the basic graph. And how do you know what the basic graph is? Well, you should recognize that there's a root there. So I'm going to draw the basic graph. Now, just to mess you up a little bit, I'm going to use 2 squares to be 1 unit. So there is my 1, 1. And then if I go 2, 3, here's 4, 4, 2. So that's y equals the root of x. You should start by that because usually that's going to give you 1 mark. Just the basic graph. This could even be like a 3-mark question. Okay? Now I see 3 things going on here. I see up 3. I see a vertical reflection. I see right 2. I'm going to do just this. What does that do? That negative affects the y, so it's going to flip it over the x-axis. So it looks like this. Okay, and I'm going to label it very clearly. That's not my final answer. My final answer is going to be, now if you don't like that -3 there, you could put the 3 on the other side. That's what I'm going to do. Okay, so if it moves to the other side, I know this is right 2 and up 3. Okay, so if you take this point at 0, 0 and go right 2 and up 3. 1, 2, 3. There it is. If I take this one at at 1, negative 1, and I go right 2 and up 3. Okay, and then if I take this one and I go right 2 and up 3. Okay, I'm even going to label that one. I know that one is 6, 1. Okay, and there's my graph. Okay, that's y minus 3 equals negative x minus 2. I like that question. That's a good question. Easily could show up on a test. Okay, so here we have, this is the graph f of x. So notice this one's a little different. The last one gave you the root sign. In other words, f of x in this case was the root of x. Okay, so don't panic too much about that. Here we're given f. In this case, you probably recognize f of x is actually the absolute value of x. But we're not told that, so we're not going to assume it. We're going to leave it. We just know that we have f here. That's the name of the function. What has happened to f of x? Okay, there's a couple things that have happened. We've got this. This is down 4. We've got this. Well, what does this half do? This half is attached to the x. It's inside the function, so it affects the x. We're going to divide the x by a half, or you can say multiply x by 2. Right? There's a half there. That's actually a horizontal stretch. And then what's the 1 do? That's left 1. Now you can do those all in one step, but that might be a little bit much to ask. What I'm going to do is I'm going to do this first, because it's a multiplying, and then I can just do a translation, which is easy. So I'm going to multiply all the x's by 2. So that one's going to stay there. What's the next x that I find easy? This one. That's an x value of 2. I'm going to multiply it by 2. It goes there. Okay, this one is 4. I'm going to multiply it. It'd be at 8. Okay, and perfectly symmetrical here. So it looks like this. Okay, now be careful. What is this graph? This is y equals f of a half x. That's all I've done to it. All right, now I'm going to go down 4, left 1. So that point's going to go there. That one goes there. And all I'm doing, I'm not looking at the entire graph. I'm taking the individual points and I'm moving down 4 and over 1. Down 4 and over 1. Okay? My advice to you is to do it with points like that. And this is y plus 4, absolute value of f half x plus 1. By the way, there is some homework questions. Let's put a little star here. Anytime you have a b value, I'm going to use this word always. Always is a great word because you know you always have to do this. There's no exceptions. Always factor out b values. Okay, what do I mean by that? Well, for example, if this was the equation, y equals f of 2x plus 4. Okay, this is sort of an example of this. What do we do here? You can't graph it. The graphing rules don't apply to this unless you factor out the b value. What is the b value? It's 2. So you're going to take the 2 out of this bracket and you end up with this. Okay? Put a little star by that. I for sure have a question in your homework on that, and I am telling you right now, I will put one on your test for sure, for sure, for sure. Now, I don't care what the b value is, whether it's a negative, whether it's a fraction, whether it's a value like 2, you have to factor it out. You have to factor it out. Okay? There's your homework. Might also add in there, maybe you want to start looking at the review because we're getting pretty close to our test. Okay. We'll stop there. This example here I'm going to do in class.